In this practical example, we will explore how to create, manipulate, and debug a float variable in Power Automate. A float variable is useful for storing decimal numbers, such as percentages, measurements, or precise values that require accuracy. We will initialize a float variable and perform several operations: addition, subtraction, multiplication, and division, while using compose actions to debug and observe how the value changes step by step. The best practice when working with any type of variable, especially float variables, is to verify each step in real time through testing. Debugging with compose actions helps you clearly track how your variable evolves after each mathematical operation. Let's begin by creating a flow. Initializing the flow. Start by creating a new flow. From your Power Automate dashboard, select Create, then choose Instant Cloud Flow. This will give us the flexibility to manually trigger the flow whenever we want to test it. Name the flow: Float Variable Manipulation. Example: for the trigger, choose Manually Trigger a Flow. This is perfect for our example, as it allows us to run the flow on demand and test the logic as many times as we need. Now that our flow is ready, we'll initialize the float variable. Initializing a float variable. The next step is to create the float variable that will be used throughout the flow. Float variables can store decimal values, which allows us to handle precise numbers. Click the plus icon to add a new action and select Add an Action. Search for Initialize Variable and select it from the list. Configure the float variable as follows. Name the variable myFloat. Type: set this to float to specify that the variable will handle decimal values. Initial value: enter 10.5. This will be the starting value for our float variable. At this point, we have a float variable called myFloat that contains the value 10.5. Debugging the initial float value. Before proceeding to any operations, let's ensure that the variable is correctly initialized by debugging it. We'll use a compose action to output the current value of myFloat. Add another action by clicking plus and selecting compose. In the input field, choose myFloat from the dynamic content. This pulls the value of our initialized float variable and displays it for debugging purposes. Name the action Initial Float Value. Giving meaningful names to your actions helps you easily track the outputs as your flow grows more complex. Now, save the flow and hit Test. You'll be prompted to manually trigger the flow since we set it up this way. After running the test, check the output of the compose action to verify that myFloat has been initialized correctly with the value 10.5. At this point, it's important to emphasize that this type of initial testing is crucial for debugging and ensuring the flow works as expected. Adding to the float variable. Next, let's perform an addition operation on our float variable. We'll add 5.2 to the current value of myFloat. Add another action by clicking plus and selecting compose. In this compose action, we'll describe the addition in plain language. Operation: take the current value of myFloat, which is 10.5, and add 5.2 to it. Result: after adding 5.2, the new value will be 15.7. Name the action Addition Operation, so that we know this step involves adding a value to our float variable. Debugging the addition. Result: to confirm that the addition worked, we'll again use a compose action to output the new value of myFloat. Add a compose action to debug the result of the addition. Set the input to the output from the addition operation we just performed. Name the action Debug After Addition. This will show us the result of adding 5.2 to 10.5, which should be 15.7. Once again, save and test the flow. The output of the test should show that the float variable now holds the value 15.7. Debugging at this step reassures us that the addition operation was successful and that the flow is functioning properly. Subtracting from the float variable. Next, we'll subtract a value from our float variable. In this case, let's subtract 3.7. Add a compose action. In this action, describe the subtraction. Operation. Subtract 3.7 from the current value of my float, which is 15.7. Result. The value after subtraction should be 12.0. Name the action, subtraction operation, so that we can easily track it in our flow. Debugging the subtraction result. We will follow the same debugging process as before. Add a compose action to debug the result of the subtraction. Set the input to the output from the subtraction operation. Name the action. Debug after subtraction. After saving and testing the flow, the output should now show 12.0 as the new value of my float. By debugging after each operation, we ensure that our flow is working correctly and can quickly identify any errors if the value doesn't update as expected. Multiplying the float variable. Now, let's multiply the value of my float by 2. This step will double the value of our float variable. Add a compose action. In this action, describe the multiplication. Operation. Multiply the current value of my float, which is 12.0, by 2. Result. The new value should be 24.0. Name the action, multiplication operation. Debugging the multiplication result. To debug the multiplication, we'll once again add a compose action. Add a compose action and set the input to the result of the multiplication. Name the action, debug after multiplication. Save and test the flow. Should now display 24.0. Debugging the flow at each step ensures that we catch any potential issues early on, and it helps build confidence that the operations are working correctly. Dividing the float variable. For our final operation, let's divide the value of my float by 4. Division will reduce the value of our float variable. Add a compose action. In this action, describe the division. Operation. Divide the current value of my float, which is 24.0, by 4. Result: after dividing by 4, the value should be 6.0. Name the action: division operation. Debugging the division. Result: as with the previous operations, we'll use a compose action to debug the division result. Add a compose action and set the input to the result of the division. Name the action: debug after division. After saving and testing the flow, the output should show that the value of my float is now 6.0. This confirms that the division was successful. Conclusion: this flow demonstrates how to initialize, manipulate, and debug a float variable in Power Automate. We've performed a series of operations: addition, subtraction, multiplication, and division on a float variable using compose actions to debug and verify each step. The importance of debugging after each operation cannot be overstated. By checking the output of every compose action, we ensure that the flow is functioning correctly, and we can easily identify where errors occur if something goes wrong. This flow can be used as a template for manipulating other types of variables in future exercises.